Hey guys, my name is Gracie. I'm from IT department section A. My topic is about economical water supply and water treatment system. Before going to the topic, I would like to ask a question. Why is water so important? All plants and animals need water to survive. There can be no life on earth without water because 60% of our body is made up of water, right? Water supply. Water supply is the provision of water by public utilities, commercial organizations, community endeavors, or by individuals, usually via a system of pumps and pipes. Public water supply systems are crucial to properly functioning societies. These systems are what supplying drinking water to populations around the globe. Aspects of service quality include continuity of supply, water quality, and water pressure. The institutional responsibility for water supply is arranged differently in different countries and regions. Urban versus rural. It usually includes issues surrounding policy and regulation, service provision, and standardization. The cost of supplying water consists to a very large extent of fixed cost, capital costs, and personal costs, and only to a small extent of variable costs that depend on the amount of water consumed, mainly energy and chemicals. Almost all services providers in the world charge tariffs to recover part of their cost. Water supply is a separate topic from irrigation. The practice and systems of water supply on a larger scale for a wider variety of purposes, primarily agriculture. From the graph, we can see that the we the usage of water is increasing from year to year. Most of the water is used in agriculture. Here, the dark green bar shows the extraction and the light green bar shows the consumption. And we can see the gray bar in agriculture, domestic use, and industry. Here, the gray bar indicates the gray band. The gray band represents the difference between the amount of water extracted and that actually consumed. Water may be extracted, used, recycled, or returned to rivers or aquifers and reused several times over. Consumption is final use of water, after which it can no longer be reused. That extractions have increased at a much faster rate in an indication of how much more intensively we can now exploit water. Only a fraction of water extracted is lost through evaporation. Service quality. So, water supply service quality has many dimensions: continuity, water quality, pressure, and the degree of responsiveness of service providers to customer complaints. Many people in developing countries receive a poor or very poor quality of service. Water quality is also dependent of the quality and level of population pollution of the water source. Continuity of supply. Continuity of water supply is taken for granted in most developed countries, but is a problem in many developing countries. where sometimes water is only provided for a few hours every day or a few days in a week. This is especially problematic for informal settlements who are often poorly connected to the supply network and who have no means of procuring alternative sources such as private boreholes. It is estimated that about half of the population of developing countries receive water on an intermittent basis. Water quality. Drinking water quality has a microbiological and a physiochemical dimension. There are thousands of parameters of water quality. In public water supply systems, water should, at a minimum, be disinfected most commonly through the use of chlorination or the use of ultraviolet light, or it may be need to undergo treatment, especially in the case of surface water. For more details, please see the separate entires on water quality, water treatment, and drinking water. Financial aspects. Cost and financing. The cost of supplying water consists to a very large extent of fixed costs, capital costs, and personal costs, and only to a small extent of variable costs that depends on the amount of water consumed, mainly energy and chemicals. The full cost of supplying water in urban areas in developed countries is about 1 to $2 per cubic meter depending on local cost and local water consumption levels. The cost of sanitation, sewage, sewerage and wastewater treatment is another $1 to 2 per cubic meter. These costs are somewhat lower in developing countries. Throughout the world, only part of this cost is usually billed to consumers, the remainder being financed through direct or indirect subsidies from local, regional, or national governments. See section on tariffs. Besides subsidies, water supply investments are financed through internally generated revenues as well as through debts. Debt financing can take the form of credits from commercial banks, credits from international finance institutions such as the World Bank and regional development banks in the case of developing countries, and bonds in the case of some developed countries and some upper middle income countries. Tariffs. Almost all service providers in the world charge tariffs to recover part of their cost. According to estimates by the World Bank, the average mean global water tariff is $53 per cubic meter. In developed countries, the average tariff is $1.04, while it is only $0.11 in the poorest developing countries. The lowest tariffs in developing countries are found in South Asia, mean of $0.09 per cubic meter, while the highest are found in Latin America, $0.41 per cubic meter. Data for 132 cities were assessed. The tariff is estimated for a consumption level of 15 cubic meters per month. Few utilities do recover all their costs. According to the same World Bank study, only 30% of utilities globally and only 50% of utilities in developed countries generate sufficient revenue to recover operation, maintenance, and partial capital costs. According to another study undertaken in 2006 by NUS Consulting, the average water and sewerage tariff in 14 mainly OECD countries, excluding VAT, varied between $0.66 per cubic meter in the United States and the equivalent of $2.25 per cubic meter in Denmark. However, water consumption is much higher in the US than in Europe. Therefore, residential water bills may be very similar, even if the tariff is per unit of consumption tends to be higher in Europe than in the US. Water treatment. Community water treatment. Drinking water sources are subject to contamination and require appropriate treatment to remove disease causing agents. Public drinking water systems use various methods of water treatment to provide safe drinking water for their communities. Today, the most common steps in water treatment used by community water systems, mainly surface water treatment, include coagulation and flocculation. Coagulation and flocculations are often the first steps in water treatment. Chemicals with a positive charge are added to the water. The positive charge of these chemicals neutralizes the negative charge of dirt and other dissolved particles in the water. When this occurs, the particles bind with the chemicals and form larger particles called floc. Sedimentation. During sedimentation, floc settles to the bottom of the water supply due to its weight. This settling process is called sedimentation. Filtration. Once the floc has settled to the bottom of the water supply, the clear water on the top will pass through filters of varying compositions sand, gravel, and charcoal, and pore sizes in order to remove dissolved particles such as dust, parasites, bacteria, viruses, and chemicals. Disinfection. After the water has been filtered, a disinfectant, for example chlorine, chloramine, may be added in order to kill any remaining parasites, bacteria, and viruses and to protect the water from germs when it is piped to homes and businesses. Here from the figure we can see that how we can treat the water in our homes from coagulation to disinfection. Water treatment process. We can see that the raw water is consists of coagulants. It is went through the coagulation and flocculation. Next, the step is sedimentation. After completing the sedimentation, it can be filtered through filtration. After filtering the water, we can disinfect the bacteria or else the wastage or else the viruses. Hence, after disinfecting the water, we can use the water for home consumptions. Learn more about water disinfection with chloramine and chlorine on the disinfection page. Water may be treated differently in different communities depending on the quality of the water that enters the treatment plant. Typically, surface water requires more treatment and filtration than groundwater because lakes, rivers, and streams contain more sediment and pollutants and are more likely to be contaminated than groundwater. Some water supplies may also contain disinfectants by products, inorganic chemicals, organic chemicals, and radionuclides. Specialized methods for controlling formation or removing them can also be part of water treatment. To learn more about the different treatments for drinking water, see the National Drinking Water Clearing Houses Facts sheet series on drinking water treatments external. Water fluoridation. Community water fluoridation prevents tooth decay safely and effectively. Water fluoridation has been named one of 10 great public health achievements of the 20th century. For more information on the fluoridation process and to find details on your water systems fluoridation, visit CDS Community Water Fluoridation page. Consumer confidence reports. Every community water supplier must provide an annual report, sometimes called a consumer confidence report or CCR, to its customers. The report provides information on your local drinking water quality, including the water sources, contaminants found in the water, and how consumers can get involved in protecting drinking water. Water treatment plant process. Here it is in the figure we can see the water plant. Household water treatment. Even though EPA regulates and sets standards for public drinking water, many Americans use a home water treatment unit to remove specific contaminants, take extra precautions because a household member has a compromised immune system, improve the taste of drinking water. Filtration systems. A water filter is a device which removes impurities from water by means of a physical barrier, chemical, and or biological process. Water softeners. A water softener is a device that reduces the hardness of the water. A water softener typically uses sodium or potassium ions to replace calcium and magnesium ions, the ions that create hardness. Distillation systems. Distillation is a process in which impure water is boiled and the steam is collected and condensed in a separate container, leaving many of the solid contaminants behind. Disinfection. Disinfection is a physical or chemical process in which pathogenic microorganisms are deactivated or killed. Examples of chemical disinfectants are chlorine, chlorine dioxide, and ozone. Examples of physical disinfectants include ultraviolet light, electronic radiation, and heat. Thank you.